We'll look at a rendezvous problem now, and the rendezvous plot, will only be for a half hour because our speed is 17 knots, which is quite a large amount to put on a plotting sheet. But it doesn't make really any difference at all. Just got to remember when it's a half hour plot, everything has to be for half an hour. Anyway, our cargo vessel in distress position is given, and it's making way at 8 knots to the position here. Now, because we've not been given the course of the vessel in distress, which we need, but if we look at the latitude, we can see it's obviously doing a course of 090 degrees when we look at the longitudes as well. So your vessel is offered to assist, and we're going at 17 knots, and our position is given. And we have to calculate the course to steer to rendezvous, the time taken, and the rendezvous position. So the first thing we need to do is work out the bearing and distance between our vessel and the vessel in distress. And we simply do that by plain sailing, as written here. Now, before we do the plot, we could just do a little sketch. There's our vessel in the centre. 033 degrees is the bearing of the cargo vessel from us, going at 090. So we can see here that our approximate course is probably going to be around 060 degrees. So the first thing we need is the course we've got to do to rendezvous. So as I say, it's a half hour plot. So we draw the 033 degrees, and then we'll put the other vessel doing 090 degrees, but we're only going to put 4 miles there, although its speed is 8 knots. And then on our compass, we're just going to get 8.5 miles, and on the end there, we're going to then score the bearing line. We then complete the vector triangle by drawing this line here, and that will indicate our course to steer. Okay, so although we've only used half an hour speed for both vessels, the triangle is correct insofar as our course to steer. But what we have to remember is this distance that we converge in 1 hour, in half an hour, the other remaining part of the vector triangle, we then convert that to an hour. So we can see that we'll converge by 11.5 miles in 1 hour. So when it comes to solving the problem, the distance that we have to, distance between the two vessels is 158.8. So we divide that by the distance that we converge in 1 hour, and that gives us a steaming time of 13.8 hours. So that gives us the time to reach the rendezvous position. Now for the rendezvous position, just simply use the cargo vessel's course and speed, work out the d long, and then that straight away gives us our rendezvous position. So that's a rendezvous plot, but just using half hour values.